us this morning for an exploration of flexible endoscopy, presented by my colleague Nick Williams, who is on the call with us at the moment. We're just waiting for a few more people to join us, and we'll kick off. We just a few bits about the Surgical Holdings Academy. So this is something that we've been running really since COVID. Ongoing. We have a number of different sessions on surgical instruments, rigid endoscopes. This is on endoscopy, which isn't actually a commercial area for us as a business. So we're looking to provide our stakeholders with key educational information to support even in areas that we're not necessarily commercially active. So open to ideas on that front. So throughout the webinar, Nick will be presenting. If you have any questions, please put them in the chat, providing you can you can actually access that. If you can't, there's a Q&A as well, which you can put questions into there, and then we'll pick those up. If there's any that seem really obvious that we need to address during the presentation, then we'll address those as we go along, but if not, we'll pick them up at the end. The webinar is being recorded, so it's now live. All of your cameras are switched off, so we can't see your cameras. So if there's any concerns with that, this is a CPD registered session, so we have this accredited, and after the session, please make sure if you're attending with colleagues that we get details, perhaps pop it in the chat around other email addresses who would like to receive a CPD certificate. So that's all good. Anything else that comes up along the way, just give us a shout in the chat. And I'm going to now hand over to Nick. I think we've got quite a few people on now, which is great, nearly 25 people. So Nick, if you're ready to go, I will pass over to you to present to us an exploration of flexible endoscopy. Thanks, Nick. And just to say, Nick Williams, obviously my colleague at Surgical Holdings, his background is working for Olympus for many years, but I'm sure he'll may give us a short intro. Thanks, Nick.
Thanks, Dan. So good afternoon, everyone. So as Dan said, my name's Nick Williams. I'm a business consultant, been working with Surgical Holdings for around about 10 years now. And prior to that, was working with Olympus for more years than I would like to admit, in a number of different areas. So I've got experience in all areas of endoscopy. And this, as Dan said, really came from our idea of Surgical Holdings Academy, principally out of the COVID break, and in all areas of education that is relevant for a number of our customers, one of which being flexible endoscopy, which, as Dan said, we have no interest in. We're not trying to sell any flexible endoscopes, accessories, or anything. So this is purely an insight into a number of areas of flexible endoscopy. And to really start, what is endoscopy? Very basic. Oscopy to look, endo, look inside. Oscopy, skopos from Greek. Endo, most things are usually from Greek. Endoscope, look inside, obviously using an endoscope. And a bit of background, as Dan sort of intimated, I've been in the industry for a long time. And there was, many years ago, it was pretty straightforward. There were two types of endoscope. There was a flexible, usually put in God-made openings, and rigid, that were usually put in man-made openings. Broadly speaking, that was the case, and really it used to be quite straightforward. There was flexible, so hopefully you can see my pointer here. This is an example of an older scope. You can see there's an eyepiece on there, so it's a fiber optic instrument. So you've got a flexible or a rigid. This is a resectoscope used in urology for usually for prostate or bladder resection. So it was pretty straightforward. That was usually used for diagnostic purposes, and that was usually used for therapeutic purposes. That was usually used in the endoscopy unit, and that was usually used in theatre. So it was pretty black and white, and it's becoming more and more grey. You now have things like this. This is a diagrammatic picture of a flexible tip laparoscope for laparoscopic surgery. The advantage obviously being that being flexible tip, you can come in and look from different angles. You could even look backwards onto the surgical area. and you get what's termed triangulation, where you want to get your instrumentation coming in a triangle, and you can quite easily use something like this to get even more options for surgical triangulation. There was also something like this, which was a number of years ago. I worked in the States for about 4 years, and NOTES was taking off, which was natural orifice surgery. And this was taking out a gallbladder, something like this, through the mouth. Or actually, when I was in New York, there were a number of gallbladders removed through the vagina. It didn't take off, principally because of the problems with the size of the instrumentation and the length of time of the procedure, and also the need. Not that many people are supermodels who care about the fact they've got a very small scar on their abdomen, as opposed to normal laparoscopic cholecystectomy, for example. So we're only looking at flexible. We do rigid webinars as well, and we can do rigid training even on site if you wish to. We also do live events, Surgical Holdings Academy Live. So we can do a number of things, but this is purely about flexible. And what we're going to be talking about today really is 4 areas. Look at the scope construction, if you like, the anatomy of a scope. Talk about some of the design criteria that you have when you're actually designing a scope, and what sort of priorities you want to give, and what compromises you have to take as a result of those priorities. Give you a few examples, not in too much detail because we don't have time for it, but in terms of the procedures where these are used, and then looking at some of the damage that can occur as a result of those procedures, or also the handling of the instruments and the processing of the instruments. So flexible endoscopic instrumentation is pretty diverse and quite complex, and to actually go into all of this would take way more than the time we've got today. So we're only really looking at endoscopes, but there are video systems, there is endoscopic ultrasound, there's magnetic imaging for colonoscopes, lots of flexible accessories like this that'll go through the scope, and there's many that go around the scope now. That I note that Olympus have signed an agreement with a robotics company for exterior instrumentation that goes on the outside of the scope. And then there's energy devices and cleaning disinfection systems. So there's a lot to talk about, but we're only talk about endoscopes. And in terms of the construction or the anatomy, I was talking about earlier, 3 main areas: the handpiece. So this is the area obviously where the hand goes, the insertion tube, which is inserted into the patient, and the umbilical. And if some of you are from different countries, that's often called the universal. So depending on the country, it will either be the umbilical or the universal. So 3 main areas. What do you need to put in that construction? Obviously, you need to see something, otherwise it would be a bit of a waste of time having an endoscope. And that optical system is usually the fiber optic or video. And you obviously need light to get there, because you can't see anything otherwise. And usually the light guide is fiber. There are some manufacturers who use LEDs. And then you need angulation wires, because the tip of the instrument needs to be moved, usually either 2-way or 4-way, so north-south or north-south, east-west. And then also internally, depending on the priorities of the scope design, you'll need channel systems for air, water, suction biopsy. There are some scopes that have auxiliary channels and razor bridge channels, depending on the use of those instruments. To look at a very diagrammatic, in a bit more detail, of the outside, we'll talk about the inside of the scope in a minute. With the outside of the scope, this is the distal tip. That's the bit that goes in the patient. There's a bending section which moves, and again, so this, using angulation knobs here, you can move this north, south, east, west. In this case, as it's 4-way angulation, you can see there's 2 knobs. 2-way angulation, you'll just have 1. Then you have an insertion tube that's connected to the control section or the handpiece by a boot. On some scopes, there are insertion tube stiffness control, so it'll be looking like this. This is actually incorrect. The artist obviously got this wrong, because you can see that this is a very short insertion tube, and actually the insertion tube stiffness control is designed for colonoscopes. because at times during colonoscopy you want stiffness that's variable. Sometimes you want it floppy, sometimes you want it stiff. So obviously they've made this umbilical or universal longer and put that in there, so that should really go there. So it's obviously a mistake by the artist. And then moving up into the control section, you have channels here. So channels here, air water suction and biopsy. On a video scope, you have remote switches, usually for freezing or for taking pictures or for changing the modality of the imaging, that can be used, are programmable. I've already mentioned the angulation knobs here, up, down, and right, left, and there's a lock, because sometimes when you're moving this, you get it how you want it, and you want it to keep it that way, and so there's a lock. This is the lock for that angulation knob, and that's the lock for that one. And then moving back towards the light source, this is the universal cord or the umbilical cord going into the light source, and then you have connections for water, air, and suction, and obviously a connection to the video processor for a video scope. So that's the outside of the instrument. What about the inside? And this picture, I think, illustrates just how difficult it is to design a scope. I mean, any given flexible scope, they're very expensive, first of all, and this is one of the reasons why they are. They are literally sort of sophisticated optomechanical instruments that are pretty well the state of the art of what you could get into a given outer diameter of instrument. And if we start from the outside coming in, you've got a polymer cover, and just that cover has taken ages to develop in terms of the biocompatibility, the compatibility against disinfectants and detergents, etc., etc. So even something as simple as the outer covering has taken a lot of time to develop. And then you have stainless steel wire mesh and outer spiral metal bands. So that is the first part of the scope. You can see here there's a wire for adjustable stiffness in certain colonoscopes. I was involved slightly with the development of this in the company that I was working for at the time. And so these three areas of variable stiffness to get the insertion tube characteristics correct took around 12 to 13 years. So that gives you an idea as to how long it takes to produce this sort of instrumentation. And then inside this, you then have your channels, so air, water, biopsy, and suction. You have a light guide to take the fibers down, to take the light down so you can see. You need obviously to then take the image back, which will either be via fiber optic, an optical fiber optic bundle, or normally nowadays by electronics, so CCD or CMOS chips at the tip, and this goes back via these wires. And then there are angulation wires, in this case 4. There are other channels such as forward water jets, and there could be auxiliary channels. So this gives you an example of the complexity of everything that's inside the internal anatomy, if you like, of the scope, which is quite significant. To look at the channels in a little bit more detail, this is obviously a diagrammatic. You wouldn't get a scope that short, but this gives you an example of an illustration of, for example, the biopsy suction channel here, the way it goes, the air water channels, and they often join just here before, and the connection through right to the light source, the water bottles, the air pump, and the suction connection. All of these obviously have to be cleaned, disinfected, and lumens, as I'm sure you know, aren't the easiest of things to clean and disinfect. So very complicated internal anatomy, hence why these, I mean, a state-of-the-art colonoscope now you can buy a very nice car for the same price. So this is why these things are so expensive to buy, and can be therefore expensive to repair. And we'll talk about the damage towards the end of the presentation. So I mentioned we'd talk a bit about design criteria, and I've already highlighted the outer diameter is the main issue. So how big do you want it when you're deciding to build the better mousetrap for want of a better term, the next generation of colonoscope or gastroscope or bronchoscope or whatever it is. So the first thing is you decide what size the outer diameter is. The bigger it is, obviously, the more you can get in, but the bigger it is, the less acceptable it is to certain patients. So that's the first thing. The second thing is, what direction of view do you want to do? Do you want to look straight ahead? Do you want to look sideways? Do you want to look forward oblique? And then you obviously need light. How much light do you need? If you're looking obviously in a large area, say the stomach, you're going to need more light than if you were in a very small area like the ureter. The type of imaging nowadays, there's lots of different imaging depending on which manufacturer you use. And I'm sure they'll all say theirs are the best, but there's white light, which is now termed TXI by one manufacturer, narrowband imaging, autofluorescence. This is autofluorescence here, which is just to show neoplastic growth. Excuse me. And then you've got RDI as an example. There's yellow, and there's all sorts of other different enhancements, and that's to show the blood vessels better. To giving an illustration, the two images there. Diagnostic or therapeutic. I mean, originally there were just simply diagnostic instruments, just to look in and not do very much else other than potentially take a biopsy. Nowadays, there's a lot more therapy done through the scope, and I would predict that's going to increase as technology gets better. More and more therapy will be done through the scope. So therefore, you need channels for that. It might be one channel, it might be two channels. Fundamentally, everything needs to be cleanable and it needs to be serviceable. And then the other aspect is the price, which I've already mentioned. These things are not cheap. If we look at a diagram of you're looking straight on to the tip of the scope, this illustrates really what I'm talking about in terms of the compromises. The outer diameter obviously being this, and for any given instrument, how much do you want to, if you sort of roughly divide this into half, the top part is the lens, the objective lens, which provides the imaging, and the light. So how much of the total scope circumference, diameter, area, scope area, if you want a better term, should be used for optics, and how much should be used for therapy? This is the instrument channel. You've got water jets and air nozzles. And if you look at this, that's a twin channel scope. So obviously more is taken up in terms of the channels and less taken up in terms of the optics. So your fundamental compromise is the best possible picture you could get is if you devote everything to just the headlights and the optics. But there's very few scopes now that actually have that, and it's how much do you actually want to balance between the quality of the optics you get and the quality of the biopsies, for example, that you get, or the quality of the therapy that you can do through that instrument. It may be you want to look, I talked about side viewing. This is what's known as a duodenoscope. So the optics is here, and most of the area otherwise is with a channel. There's a razor bridge here, which moves. It's an elevator which moves like this, and moves whatever device you want to put through it, whether it be a basket, catheter, or whatever, and will move accordingly to get into the sphincter, which we'll talk about later. Or you may get something very sophisticated like this. This is an EUS scope, an endoscopic ultrasound scope, where you've got a normal scope up to here, quite a small area that's been devoted to the optics, then a razor bridge mechanism and a channel for fine needle aspiration for taking biopsies. And then at the tip here, you've got a curvilinear ultrasound transducer that emits ultrasound into the tissue in this plane, and then you use the needle to take a sample from the area that you're looking at taking the sample from. And I'll show you some pictures about that shortly. There are also weird and wonderful scopes. This is actually quite an old shot of a note scope that was a prototype that was produced 20 years ago, and I was actually in the States when notes took off. I actually think it's a very elegant, the reason I'm showing it, I think it was a very elegant design. It was actually, I think, by Storz. And obviously these jaws here would close, go in and then open up, and you get your surgical triangulation. The optics is here, and a number of channels to do that. I thought it was a very interesting development, and there are now things that are being developed looking like this. All of these are prototypes, really, but equally with this, where this improves over that is in terms of that is your optics, and now you can actually move your optics to do much more like the flexible tip laparoscope that I was talking about earlier. So these are certainly the shape of things to come. How much they are taken up depends on a lot of things, and one of the biggest things is cost, because a lot of these things are very expensive to produce and service and repair, and as opposed to whatever the previous sort of surgery that was being done, how cost effective is it? And so on that, let's look at some of the procedures where these are used. There are a lot. The vast majority are upper and lower GI. So in GI endoscopy, which is gastroscopy for upper, colonoscopy for lower, strangely enough. ERCP, which I'll talk about in a minute, that's endoscopic retrograde cholangiopancreatography. EUS may be used in all those areas plus bronchoscopy. Enteroscopy is small bowel endoscopy. And obviously also you have with that the pill cams and things like this. Bronchs, obviously for the lungs, cystoscopy, strangely enough, for the bladder and prostate in men. And then you have upper tract scope for the ureter, and reno, obviously, for the kidney. So lower and upper tract from the urological perspective, and upper and lower tract from the alimentary canal perspective. Then ear, nose and throat, gynae, and also in difficult intubation with anaesthetists. There are other areas, neuro, there's all sorts of weird and wonderful things, but in principle, that's the most of them. And I would imagine most of what you'll see in hospitals will be upper GI, some bronchs, and a bit of cystoscopy and well, a bit of urology, ENT too. But the upper GI and lower GI are the principal ones. Let's talk about upper GI first. So gastroscopy, very straightforward and simple. The patient swallows the scope. The esophagus will be looked at. This is an American, sorry, there should be an O on that for the UK. Into the stomach, look around the stomach into the first part of the duodenum, and you'll see pictures like this. This is a gastric ulcer, and the procedure, very quick. Personally had a few myself, and very quick and simple. If you do have one, find someone who's quick and gentle. I have mine without sedation, so it's pretty straightforward and very well accepted. Moving down to the other end. So colonoscopy. This is an example of a picture through a colonoscope. Colonoscopy has really moved from being purely diagnostic to therapeutic, which I'll explain in a minute. But colonoscopy in general, it depends on the country and the orientation on colorectal cancer. In this country, we're very lucky that we have. So those of you, sorry, who are not from this country, apologies. I'm bigging up the UK NHS. We have colorectal cancer screening in the UK. So over a certain age, you'll be getting a blood test in your stool to see if you've got anything. And if you test positive for that, you'll then go in and have a screening colonoscopy, which will say if there's anything there or not. And quite often, if there is something there early, it can be dealt with and you're cured. So that's the beauty of the in terms of endoscopy in the colon. If you get colorectal cancer early, it really can be cured. And to help getting it early, we've had a lot of questions about AI in the past in the Surgical Holdings Academy, and I just thought I'd digress slightly on that because where AI is to a certain extent sort of technology looking for an application in many areas of industry. With medicine and certainly with endoscopy, GI endoscopy, the main area is really being in helping diagnose difficult to find lesions. And this is an example of one of the AI products that are there. This is Medtronic thing, which showing without Genius, you've got an area that looks a bit dodgy there, and with GI Genius, you'll get a something which is alerting your attention to that, to have a look at it a bit more. I think this illustrates the problem I have at the moment in terms of, I don't think it's quite there yet. I mean, that picture to me looks more dodgy than that. So I don't think the product manager has done a great job for the product there. What you really want to see is something that's a bit more like that, and then something like that with a box around it. Olympus have also done something similar, where you've got something around that. But again, I mean, really, if you're an experienced endoscopist, you'll look at that and think, yeah, that's not right. What you really want are the things that find things that you will have missed. And there was a study that done recently on one of the products from one of the companies, which highlighted there was an improvement of adenoma detection in the colon from about, I think it's about 36 to 43%, which isn't a massive increase. But equally, if you're a patient that would have gone on, you've got a problem that would have gone unnoticed, and you then developed a rather nasty colorectal cancer, and the AI has done that, then clearly that's a major development. But I did want to just highlight some of the negatives of AI, and this was something which I've taken the top off, because this was put on LinkedIn by someone who wanted to promote their own wares in terms of endoscopic equipment, and highlighting that, you know, when the disinfectant becomes a source of contamination, and look how terrible that is, oh my God. And looking at that, how horrendous is that? It looks like that's gone through an autoclave. But as you can see, that is the universal, the umbilical coming out, and actually it goes into where the insertion tube is. And this is the insertion tube, which doesn't seem to be connected to anything. So AI hasn't really done a very good job there. And interestingly, some of the AI people, so for example, the CEO of Google first said AI is something more profound than electricity or fire. And at the end of last year, he said, do not blindly trust everything AI says. I'm slightly paraphrasing there. So even some people with huge commercial self-interests are saying, you know, we're not quite there yet with some of this. But equally, I'm sure there'll be a lot of cherry picking with some of AI that should be very interesting. So getting back off AI and back onto colonoscopy, hopefully AI will stage very early cancers and find that very quickly. And one of the benefits of colonoscopy is, with a flexible instrument, is you can go in, stage it early. You could then use EUS to see how far it's gone in, so endoscopic ultrasound to see how far it's gone in, and then potentially then take it out, if you can take it out there and then, and the patient is cured. An example of that is EMR, which is endoscopic mucosal resection. Excuse me, where basically you use a normal scope, you put a needle in, you inject fluid with a dye, it's usually indigo carmine, and then put a snare around it and chop it, and then remove it with some forceps. What that looks like in reality, you can see this is blue, this is with the indigo carmine, and you can see this is the area that they want to take off. They'll put a snare around that, and then you're left with something like that. And that is cured. I mean, that's obviously highly magnified, so it looks a little bit more brutal than it actually is in real terms. But you know, a very elegant technique using current technology, none of this sort of fancy triangulation stuff that I showed you earlier, and the patient is sorted. So quite exciting stuff, and I see sort of colonoscopy moving very much more towards their therapeutic colonoscopes. What about other areas? ERCP, another area that many years ago when I first started was primarily diagnostic and then became therapeutic. So to just explain ERCP, so endoscopic, you need an endoscope. R is retrograde, you're looking back on yourself. Cholangio is to do with the biliary system. P is pancreo, to do with pancreas, which isn't on this. You can see a pancreatic duct there, pancreas is there. And ography using fluoroscopy. So endoscopic retrograde, cholangiopancreatography. And what happens is you get a scope that's put it into here. It's a side viewing scope, and you'll use flexible through the scope devices to go into this ductal system here and diagnose and potentially treat stones, etc. This is a good example of what you'll see. So this is the endoscopic view, and this is the fluoroscopic view. So this is the scope. You can just see there's a little accessory coming out, and then all of this black is a dilated biliary system. So there's obviously a blockage here, and as the liver continues to produce bile, you get if you like, a bile roadblock, and it just dilates the entire system. This is the stone, which will need to be removed or broken and then removed. And then all this bile can then come out and act normally. And in the case where that also blocks the pancreatic duct, you'll get that same problem with pancreas, and pancreatic juices can even start to digest the pancreas itself, and you'll get acute pancreatitis, which obviously isn't very nice and needs sorting quite quickly. EUS, another one of the more sort of technologically complicated procedures. There are a number of different scopes. There's radial imaging where it's going in the plane of the scope, and there's imaging where you're going in this plane. This is an example of a radial picture, and these are examples of pictures through a fine needle aspiration scope. So the needle will come out through here, and you'll be imaging in that plane. So you'll then see the needle go into an area that you're interested in. And this is the ultrasound picture. So this is the area that looks a bit dodgy. So you can see it looks different from the normal tissue around it. This is the needle coming in, and you then take samples from this area. So again, quite an elegant technique, which gets you samples right exactly where you want to take them from. In terms of other areas, so in urology, cystoscopy, and what I'll call uretes, or ureter-only rhinoscopy, you will have something that looks like this, and depending on the lower tract is so the urethra and the prostate in man, and then the bladder, and then the upper tract is the ureter and the kidneys. And obviously you need longer scopes for the latter. This is an example of ureteroscope, a flexible ureteroscope. There are also semi-rigids that will go into the ureter and then sort the patient out. And in this situation, these are pictures. This is fluoroscopy, also done under fluoroscopy. So you can see there's a stone. That's the stone in the endoscopic view, and then you'll gradually you'll go in and chip away at it either with a lithotripter or with a laser. So chip away the bits, remove the bits, and then you're left with a nice, clean, open ureter. So the patient is and the same thing happens in terms of if you get a blockage, then this area of the kidney dilates, and you get what's termed hydronephrosis, and the same sort of blockage issue that we were showing with ERCP earlier. So once you've cleared the blockage, you can obviously then go back to normality, or normalcy, as the Americans would say. Bronchs, pretty straightforward into the lungs, and you can do EBUS, which is the endoscopic ultrasound through bronchs as well. So you'll have a little ultrasound transducer at the tip there, and do the same thing as I showed you earlier in the upper GI tract. This is an example of a tumor, and obviously then take it out. One of the problems with lung cancer as opposed to colorectal cancer is there's no real lung cancer screening program, and often bronchoscopists will see cancer at a later stage. But there's obviously a lot of work being done on trying to improve that. But we don't have any lung cancer screening at the moment. So that gives you an example of a number of endoscopic procedures, and what you've probably got a feel for is a lot more therapy, a lot more is done through the scope. And as more things go through the scope, these things, particularly if they're, for example, like a laser, where I showed you on the here, if you're lasering that, you've got a laser fiber which can be quite sharp. So if you've got a tip that's bent quite a lot, that laser fiber can damage the internal channel of the scope. And as therapeutics has taken off, damage internally has also taken off. So let's talk about damage. Now, external, there's a lot of mechanical. You can smack things due to shock damage. There's bends, dents, and cracks. They can get cracks in the insertion tube purely because the insertion tube is old and it's being used a lot. Shock damage, usually used to dropping, catching it in something. The classic thing is if you hold a scope like this and you just let the distal tip swing around, do not do that. Make sure you always have the distal tip in the same hand, or you've stopped it swinging around, because obviously if it swings around and hits something while you're handling it, not good. Internal and to a certain extent external as well, therapeutic devices. If you've got a lithotripter at the tip moving around, that can damage the tip of the scope. Lasers, there are lots of cases where lasers have been fired internally by mistake, and then obviously blows a hole in the channel. Chemical, we haven't talked about disinfectants and detergents, but obviously if you take disinfectants as an example, they have a problem in terms of they need to kill bugs, but they can't kill humans and then damage humans in any way, and they certainly can't kill scopes. So they have to kill bugs, but they can't harm humans, they can't harm scopes. That's not an easy design brief. And there is autoclavable and single patient use technology out there, but there's significant cost implications. So, you know, in general, you're talking high level disinfectant usage with a state-of-the-art expensive instrument, and it's important to avoid fluid ingress because that's costly. So if you remember, this picture, so if you've got a laser fiber, for example, going through there, or firing and you get a hole in the biopsy suction channel, and you then put it through a cleaning process, and the disinfectants will get internally. You've got fluid ingress, and if that then gets to the CCD or the CMOS chip and blows it, you're talking about very expensive repair, thousands, maybe over 10,000 in some cases. So you obviously want to avoid that. So to summarize, these are state-of-the-art optomechanical instruments for a given diameter. What you're actually getting in them by pretty well all manufacturers is pretty incredible. Cleaning is nothing like as simple as rigid endoscopes. You don't have the same issues in getting through long and cleaning and disinfecting long lumens, and they're a lot more expensive than rigid instruments, both in terms of initial cost and ongoing repairs. Care and maintenance is important because you will break them. Particularly the thinner instruments, they will break. It's just a question of when. And there's many different forms of damage. What you want to do is avoid the major repairs that are in thousands, when the minor repairs, for example, a bending section rubber or a slight blockage, are in hundreds. So avoid the major repairs, and the main cause of that is fluid ingress. So if you can avoid that, you'll save a lot of money to your hospital, and if you're in the NHS, the NHS. If you don't remember anything else about this presentation, is that your endoscope supplier should have teams of people that are available to help you with care and maintenance training and cleaning and disinfection in many cases. So use your endoscope supplier for care and maintenance training. They are there. It's a valuable resource. Do use them. And really, it's all about stopping those major repairs. So to quote Einstein, intellectual solve problem, genius to prevent them. So if you do prevent those fluid ingress repairs, you will save your hospital a lot of money. And that is it. Thank you.
That's brilliant. Thanks, Nick. Extremely insightful, and some of the technology is crazy in terms of the progress that's been made, and obviously the primary importance is diagnosing people quickly and ensuring they get well quickly. So it's great to see that that coming on leaps and bounds. I mean, just while we're waiting, if anybody has any questions, please pop them in the chat there. As I mentioned, I was just interested. A couple of points I've written down. What obviously we have rigid endoscopes as well. What's generally, how do the quality of the optics compare, the quality of the picture, if you like?
Well, it obviously, I guess you'd have to compare similar outer diameters to each other, but rigid instrumentation is done through well, a rod lens system. So either what's termed as a Hopkins, who was actually someone from the 60s who invented the rod lens, or a hybrid rod lens system with achromats in between, and sort of normal lenses, if you like. So it's the optics actually through those are very good. There are chip on the tip instruments, so chip on the tip laparoscopes as well, which will be the equivalent to a video flexible endoscope. And so the answer is pretty similar in terms of for a given diameter. You could argue that actually a very inexpensive 10mm laparoscope, which is just using rod lens or hybrid rod lens technology, will be excellent and better value than the same size outer diameter flexible instrument. Obviously, as I've shown, the internal anatomy is a lot more complicated.
Yeah, and what's so something like a cystoscope, you get flexible and rigid.
Yeah.
What why what would be the benefit of one over the other? Is it clinician's choice, or is it diagnosis, or what's the process?
Well, if you compare, say, for example, a fiber optic cystoscope and a rod lens cystoscope, the rod lens will give you better optics. But if you're a patient, I can tell you absolutely which one I'd rather have into my urethra looking at my prostate. And obviously flexible move with the natural anatomy in a patient, and the rigid will kind of move that anatomy around it to make sure it's a rigid. So flexible cystoscopy is done under local anesthetic, and rigid cystoscopy is done under GA in general. So it depends who you are.
So it's much beneficial for a quick turnaround as a patient.
Yeah, I mean, there's two of us here. Benign prostatic hyperplasia or big prostates happens to 1 in 3, and so out of the first 3 on the screen that I'm looking at, one of us is probably going to get a problem, and so I think we'd much rather have a small flexible instrument inserted into our urethras than a large rigid. At the risk of sounding slightly crude.
I see where you're going with that. Yeah, certainly, and can agree. The other thing, autoclavable scopes. Why hasn't that emerged? Because obviously, clearly there's a lot of challenges with maintenance and cleaning things properly. But if that's an option, why hasn't that become a routine part of use?
Yeah, I mean that doesn't really make a lot of sense to me. When I was, I've not been with Olympus now for 10 years. Probably about 15 to 20 years ago was the first time we really were looking at testing autoclavable, and there were autoclavable prototypes. The answer, I think, is you just can't make them financially attractive, because they break quickly. They break a lot more. I mean, we probably right now in many of the hospitals of I'm just looking down the thing. So Leeds and Royal Devon and Exeter, for example, I'm sure you can find instruments there that are 10, 15 years old. Would an autoclavable last that long? No. And they'd naturally be more expensive. So I don't think you're getting the return on investment for that extra cost. So that's why I don't think there's been a lot of development in that. There's certainly been development, but a lot of development that's led to an actual product on the market. And the other side, same with single patient use. There's a lot of single patient use scopes out there, but you just throw it away.
Yeah.
And so you're compromising the quality of. You're going to have to compromise the quality optically and handling characteristics and everything else to get something that's affordable for a single patient use item. If there's single patient use people on the call, I'm sure I'll get lots of questions saying, why do you think that is? But pretty straightforward.
I'll see. So somebody on the call, Stephen, said when scopes are sent back for repair or service, is there a full report sent back to the user to inform of any of other issues found? Thinking of scored channels due to excessive brushing, this would be helpful in improving cleaning methods. So also, what are thoughts on automatic cleaning systems, and will these be added to endoscope reprocessing IFUs, do you think? So,
Well, if we take that sort of bit by bit, I mean, when scopes are sent back repair for a routine service, it depends on your service provider. Are you using the service provider? Is it is it the OEM or is it someone else? To me, they should produce that. You should have that, and certainly, from my own experience, if, for example, you send a scope back and you're on a service contract, then everything that's wrong with it would be fixed. If you're not on a service contract, it's chargeable repair, then you'd get you'd be contacted by the company saying, right, well, you've got this problem which we'll fix, which will cost this, but you also have this problem. So I think the example you've used is scored channels due to excessive brushing. It could also be used for the surgeons using a new laser fiber, for example, that's quite brittle and quite nasty at the tip. So yeah, the answer to that is it should happen. I don't know if it's not happening with your supplier, then check and maybe ask them. But there should be some form of a full report sent back
with an alert to flag anything that looks like it could potentially become costly.
And again, sort of, I mean, certainly, I mean, a lot of instruments are on service contracts now, and the company that you're dealing with, you should work with that company who's providing the service to sort of see trends. If all of a sudden you're starting to have increased repairs, have a look at those trends and see what it is. It might be a new colleague that hasn't been trained properly. It might be a new surgeon that's doing something weird and wonderful in a new device that no one knows about that's causing problems. But certainly, again, in terms of prevention, if you look, you see those trends early and work closely with your service provider, then you can nip that in the bud and not have massive load of repairs that are 10 grand plus.
Yeah. And I'm not too sure about the automatic manual cleaning systems.
There
referenced.
are automatic out there, and there's many of them. And obviously, there may be some people on the call who will pick that up and say, "Oh, can I sell you my own?" But would they be added to endoscope reprocessing IFUs? The problem from an endoscope company perspective is there's all sorts of different ones, and there's all sorts of different ways of disinfectants and detergents and everything else, and so that has to be fully tested before it could be added to an IFU. So I think it's unlikely that you'll get IFUs that include every scope cleaning manufacturer and every detergent and every disinfectant, because that's a hell of a lot of work.
Yeah, and you can't. I mean, as we see on the instrument side of things, you can't possibly cover every single combination.
No,
some of that potentially, some of that's got to be on the trust, doesn't it?
Different pressures. So all you got to do is change one variable, and you're in trouble.
Right. George has just said, so scopes have service dates. If a scope's just come back from repair, i.e. today, and its service is due next week, should it still be sent for a service?
Well, ideally you get it done at the same time, but I would say definitely have services, and also manufacturers who do service unconditional guarantees, make sure that when it comes to the end of that guarantee, you get it serviced before the end of that guarantee. Because you might pick something up that is obviously under the guarantee that you'll get for free, rather than 2 months later you'll have to pay for it either on a chargeable or you're paying for it effectively on a service contract.
And if it's obviously part covered under the fee anyway, it wouldn't really matter too much, providing you're not paying extra for that service, I presume. No,
if it's covered under the contract, but equally a contract is basically an insurance model. The more you, if you like, more claims you have under that premium, the premium will go up eventually. So ideally, and if you literally got something that could be covered on the guarantee, get it covered, and then obviously it will take that claim away from your claims record for the first year of your service contract.
That makes sense. We haven't got any other questions on the moment. I had couple more things. So Gina has added they have a scope health check once a year.
Yeah.
Should the scopes have a service as well? So should they be serviced? Is it a routine Yeah, I
Again,
suppose
I think
like
it
a
depends
sort
on
of,
the company and the service provider, but I would say yes, that's sensible. I mean,
yeah.
an example I would give is the angulation wires. I'll use the gastroscope for it as an example. The angulation wires on a gastroscope will start to move, and you get less angulation. So in order to get, you can see my finger, you get sort of like a U. A way of doing it is when you get it new and you draw around it on full angulation and then compare it to that. And if it starts to do this, what will happen is the physician or clinician, physician or surgeon using it will just keep pushing, tugging at the angulation knob more, and eventually it will break. And that
Mm.
is a reasonably expensive repair. Whereas if you had a service and you just saw that those are moving and it gets readjusted, that saves money there.
Yeah, I mean, I think overall we want to be changing the mentality to how medical devices are managed, don't we, in the hospitals to be to proactive service
Yeah,
rather than very expensive reactive repairs, because
yeah,
because obviously,
absolutely.
but it's trying to change what's the standard, isn't it, and trying to create a new a new process really that's not necessarily always been there.
Yeah, but
Um,
equally, I mean, I would just diarise something. We've all got electronic diaries. Diarise something, and you can put it in a diary, and so that twin channel gastroscope goes in April, and that other one, the 10 other ones, we gradually diarise over the summer, and
mm,
obviously, do it when you're not that busy. So, don't do it, um, don't do it at peak times.
yeah, that makes perfect sense. Um, so there's clearly seems to be a lot of progression technology wise. Not that I'm suggesting you're really old, Nick, but
Right.
what did this technology look like? Originally, like with the scope similar. Have you seen? I know you've shared some of the developments, but were they comparative in terms of the functionality and how they
Yeah,
worked
I mean,
originally?
there's been,
Yeah.
I've been in it 30 years, and there was an amazing technology advance in that 30 years, and on both sides. And so if you take sort of flexibles, I mean, early gastroscopes were it's quite a poor fiber optic bundle in them. It wasn't that great to see, and obviously as you break those fibers in there, they'll gradually break, and you'll get less, inferior optics. If you take the rigid side, I remember the early laparoscopic cholecystectomy cameras. As soon as you got a bit of blood, there wasn't a good enough light sensitivity, so everything went dark. As opposed to now, fantastic on both sides. The images of the stomach you can get through the state of the art flexible gastroscope now, phenomenal, and lots of different imaging modalities that weren't there before. And with the lap chole sort of rigid side of things, amazing. Almost, you can get 3D, but you're almost getting 3D sort of resolution through 2D and 4K
Wow,
and everything else. So it's come on amazingly. I mean, it's sort of chalk and cheese.
incredible. No, that's. I mean, it's from a medical device innovation perspective, that's very exciting, isn't it? And obviously, particularly with the introduction of AI and robotics and some of these newer technologies, obviously it remains to be seen how the AI will impact. So yeah, no, that's great. And in terms of, we haven't had any other questions come up, so I'll just finish with one other final point. In terms of, I think we're on the call. We've probably got users of the scopes as well as colleagues who are handling these and processing them for cleaning. So, what would be the sort of you've mentioned your key takeaway, but I'd written that before you'd said it, but is that just really respect of the what is inside the scopes themselves and how delicate they are. You've got things like you mentioned things like the objective. I mean, there's real expensive components there, aren't there? I know in rigid scopes they're particularly expensive, but yeah, to save the hospital money, what would be your sort of key advice there and takeaway?
Uh, well, I think one, protect the tip. So don't, always be aware of the tip. Two, work with your supplier, your service supplier, your endoscope supplier, if they're not the same. Work with both of them to really sort of be wise to things. and just notice. I mean, if you're signing off repairs on scopes, and all of a sudden you sort of, just kind of, if there's a way of logging it, or just, have a mental sort of background view if this is starting to happen a bit more, or if you're seeing it's another repair of that type, then just flag it and get in touch with your local supplier and just say, can we have a look at this? And they can do, they have all the data. They can just do a report and see, and you might think it's a trend, but it actually isn't, or it might be a definite trend.
Yeah.
So
Yeah, and that should become quite apparent, shouldn't it? But
yeah.
lots of the sort of accidental damage, I've seen some of the like silicone protectors that you can buy for the endoscopes, and that
Yeah.
that makes sense. Whether that would be recommended by the manufacturer, but obviously that's preserving the scope, isn't it? So
Yeah. And the other
indeed.
thing, obviously, that I haven't mentioned is if you change your disinfectant, for example, or you change your detergent, or something like this, then quite often that may lead to problems. I mean, there was a few detergents that came on the market over the years that caused problems with scopes.
Mm.
So that may be another source of a problem that you can nip in the bud. But if you've actually changed, that can be a problem.
Yeah, definitely. Okay, Nick, that's brilliant. I don't think we've got, just check the Q&A. Haven't got any other further questions. If anybody has anything that comes to mind, feel free to email me. My email's on the chat there directly now. So thank you, Nick. Great presentation there. Really appreciate you taking the time to go through that for us. CPD certificates will be coming out. Anything else to mention, Nick, before we sign off?
No, well, just if there are any other, as I say, this is an ongoing thing. We do this regularly. If there are any other areas of education that you want, that you feel is lacking, and can we look at that? Then if we couldn't, we might be able to get someone who can.
Brilliant. Thank you. Thanks, everybody. And we will send out details of our next event coming up. Thank you very much.
Cheers.
Bye.
Bye.